Um, right, so welcome to the second day of Bootcamp, and welcome to this presentation about the technical directions for VMS. I'm going to use some speaking notes for this session because I've got a lot of material, and if you just let me ramble on, then there will be no time for questions at the end, and we don't want that. So I want to start with our vision or mission or whatever you want to call it. um, by linking the past to the future, we provide OpenVMS users an opportunity to protect and realize the full value of their application investments. Now, you have heard these sentences before, probably, but I think they're kind of important because this is what we as a company are all about. We're not developing OpenVMS because it's such a fun and great operating system to work on. Well, we are, but we're not getting paid to work on it for that reason. We're getting paid to work on it because you, as our customers, ISVs, partners, have invested money into developing and maintaining applications in OpenVMS. And we want to make sure that those investments will continue to pay off well into the future. So what I want to do today, rather than do like a whole roadmap presentation, is take this strategy and show you how we work to translate that into a strategy and deliverables for OpenVMS. So I want to look back a little bit on the last 10 years. Then I want to tell you about our product organization. Then we get to the technical directions, and I'll give you some specific examples of what we plan to do when it comes to software development, storage, networking, and the OS. And then I'll have some highlights from our roadmap for you. So before I do that, I want to say a few words about the incredible team we have at VMS Software. And when you fly into Boston or pretty much any international airport, you often are greeted by a sign that says welcome in a dozen different languages. So I try to think of as many languages that the people in our offices and working from home around the world speak. And I came up with this slide. And we have a geographically diverse team, but we also have an incredibly talented and otherwise diverse team. And of course, we have a team in the US that consists of seasoned veterans in OpenVMS. And then we also have teams like the one in Yerevan that have a few years under their belt now. And we have teams like the one in Greece who just got started and are still learning the basics. And we believe that it is vital for the future of our company and for the future of VMS that we pay a lot of attention to sharing knowledge. We need to make sure that the people in Armenia and the people in Greece become as well versed in OpenVMS as our veterans. So we are taking a more active approach to make sure that this happens. That means that we'll have people traveling to facilitate knowledge sharing. It also means that we take some people away for some time from actually working on the deliverables for the short term. But we believe that that is necessary to keep delivering consistent results in the long term. So during this presentation, I want you to keep in mind that while we are all working to meet today's challenges, behind the scenes, we are also working on our ability to keep meeting the challenges of the future. So let's look back a little bit on the last 10 years. So when VSI started, we only had one real main goal, and that was to port to x86. Hewlett-Packard, as you recall, announced that they were stopping all development of OpenVMS. But they also announced end-of-life dates for the hardware that VMS ran on. So at that point, OpenVMS was stuck with no future at all. A platform no longer supported, running on hardware that would go out of support pretty soon, and nowhere to go. So getting to x86 was vital. Getting out of that situation was vital. And we think that the only viable option to secure the future of applications on OpenVMS at that point was to port to x86. Now, fortunately, we had a team that was experienced in the mechanics of porting the operating system. Claire Grant in particular was present for all three of the ports, and he led the previous port. So Claire will have a session later today where he goes into those three ports and how they differed from each other. But we had a pretty clear plan on how we were going to achieve this port. We had the porting playbook. We didn't have a lot of the details yet when we got started. It's one of the reasons I got hired, is to fill in some of those details when it came to like low-level bit twiddling on x86. But we did have a plan, and we roughly knew what steps it would take to get to x86. What perhaps we didn't realize as fully is what it would mean to go from proprietary hardware, all made by the same vendor or succession of vendors, and all having some sort of like relative consistency between those platforms, and to take that and go to a platform that is multi-vendor and where every vendor has their own idea of what an x86 machine should look like. On the surface, they all look the same, but if you get into the details of like the UEFI firmware, there are big differences between different hardware vendors and between different hypervisor vendors. So while we were porting to x86, pretty soon we also started getting engaged in a whole slew of other projects, because we found that an operating system that had been, I think yesterday the term was benign neglect, an operating system that had been neglected for a decade or so, maybe even more, had some deficiencies that were too urgent to wait for the port to x86. And we had customers banging on our doors, can you please fix this or that problem for us? So we ended up doing things that originally weren't part of the plan when we decided to port to x86. We decided to do alpha versions of the OS, and we did a version that was optimized for performance on later alphas. We did things like the port to Java. And we started developing some more modern tools for system management and for software development, like the VMS IDE. Some of the projects we started, in retrospect, were maybe a bit too big for us to dig our teeth into, like the new file system project that we started not once but twice, and which ended up, well, I wouldn't say it's going nowhere, but for now it's not on the roadmap. Now, in the middle of all these projects going on, as a company, our development team expanded over the years, and we had to keep the company afloat. We needed to generate some revenue, and more revenue than we were generating. So what we did is we negotiated with HPE to take over the support contracts that HP had for VMS customers. As a result of that, we had to considerably grow our support team. And I don't know if Debbie's, there you are. She's sitting right in front of me here. So thanks to Debbie and her colleagues and her predecessors, we have an incredibly talented support team where you really see the knowledge transfer taking effect. We've got some veterans in the support team. We've got some younger people in the support team, and they're all learning, and that's just incredible. Knowledge sharing, sorry. Oh, yeah. I keep telling everyone we don't call it knowledge transfer, we call it knowledge sharing, and now I make the same mistake myself. So we have a very professional team who are able now to field most of the support calls without having to involve engineering. And that means that engineering has more time to work on what they should work on. So we also found that we were getting questions that went beyond simple support. Questions on how to build applications on OpenVMS, or how to put together a VMS environment. And so we also added our professional services and application services teams. And we're now even talking about doing managed services. With more than 1,000 customers, we also had to change the way we interacted with customers. We had taken a stance where we would let the customers come from us. And we called it sales. Now, under Jan's leadership, we have transformed that into an account management organization. And the big difference is that they actively reach out to our customers because they realize that our customers are key to our success. So rather than wait for the customer to come to us at the time when their needs need to be met immediately, they try to reach out to all those customers proactively and figure out what it is that we can do to help them over the next few years. So they really drive that customer engagement. And then when we managed to finish the port to x86 and we released it, our engineering team then got overwhelmed with questions. Through our sales organizations, we would get questions like, can you also provide this particular function? Or can you also port that bit of open source software? Or can we run OpenVMS on that specific brand of servers? Through support, we would get questions like, is this feature working on x86 or not? And through our professional services organizations, we would get questions like, well, we know how to configure this on Itanium, but is there any guidance on how to do this on x86? And in retrospect, we may have been so focused on getting the x86 project out the door that we hadn't thought as much about what are we going to do once we get there. Now, I've got a question. I want you to raise your hand if you're a software engineer, or if you work with software engineers on a regular basis. The question I have is, what answer do you get if you ask a software engineer, can you add function XYZ to your application? In my experience, the answer you get is often a variant of yes, if, or like you say, it depends.
The other good one is, it's already there if you do this.
Right. So what problem are you trying to solve? I like that one. So when we finished the port, we were a pretty engineering heavy, engineering driven organization. So those questions that our customers had ended up in our engineering department. And with no clear strategy or sense of direction, we found that our engineering efforts were being pulled into all sorts of different directions at once. As a result, unfortunately, we weren't always able to provide customers with clear answers to the questions they had. And we weren't able to provide our sales and support organizations with clear answers to correct questions. And that, of course, then leads to confusion and more questions. I'm sure some of you can recognize what I'm describing. Another effect was that at times we were overly enthusiastic in adding all these requested features to our roadmap. And at times we ended up having to walk back the promises that we made to our customers. And that, of course, is never a good thing. So what are we doing to fix this? Well, in 2024, this year, we have established our product organization. And the product organization consists of myself, Daria, and Nikita. Now, Daria, as the CEO, of course, is responsible for all of our business objectives as a company. But all these strategic decisions we make about our products need to be in line with those business objectives. Nikita, as product manager, is responsible for open source, several layered products, but also for the partner and ISVs programs. And Nikita is standing in the back of the room. So you can see what he really looks like rather than in this fuzzy picture. And then I am the product manager for the operating system, networking, compilers, and some related products. Now, my job title is Chief Architect and Strategist, and that means that I'm ultimately responsible for determining the strategic directions that we take the development in. And at the same time, it's up to me to safeguard the architectural integrity of the operating system. I need to ensure that the decisions that we make are in line with our business objectives, and then I work with our engineering department to deliver on those strategic decisions. So I wanted to capture what the product organization provides to VMS software and to our customers. So first of all, by establishing a clear strategy for our products in alignment with our business objectives, we provide our engineering department and the rest of the company with a sense of direction, because we really need to know where we want to end up. And then secondly, we gather wishes and requirements from our customers, from our partners, but also from all other departments in VSI. Of course, the questions from our partners and customers often come through sales, support, or services. And if we combine that input that we collect also at events like these with our strategy, we can then come up with a list of features that we want to add. And we can make that a prioritized list where we determine what's more important and what's not. Then thirdly, we work closely with our engineering organization to take that list and translate it into work items that need to be done. And then we can establish a realistic plan on how to do that. Who works on it? When can it be finished? And ultimately, that should result in a consistent and realistic roadmap that we keep up to date. Based on that roadmap and our strategy, our engineering organization has the information it needs to determine what to work on. They know how our strategies or how those priorities fit into our strategy and into our roadmap. And we make sure that all our engineering efforts are aimed at delivering on that roadmap. It gives the company a sense of control over what we deliver and when we deliver it, and it hopefully diminishes the risk of unpleasant surprises for us, but also for you. And I know that there have been a few of those over the last few years. And then by establishing all these processes, we as the product organization should have all the necessary information available at our fingertips to provide clear answers to customer questions and to provide a sense of clarity, both internal and external. And that's, I think, what we've all been looking for the last few years. So, any questions about any of what I've talked about so far? Because I want to move on to some actual technical directions, because that's what we're supposed to be talking about today. So our technical directions. Now, this is where you might expect to see a bunch of roadmap slides. Like I said before, that's not what I'm going to do, because our roadmap is up on our website. We try to keep it as up to date as possible, so you can find the information there. And to be honest, presenting a deck that consists of a bunch of roadmap slides is very boring. It's boring for me, and it's probably boring for at least half the people in the room as well. So I will have a few highlights at the end, sort of like a mini roadmap, but I'd rather show you what kind of features we are thinking about. And our main objective, of course, is to get our customers to x86. And I've defined like 5 major themes that we use to accomplish that. So the first one is we want to retain the core strengths of OpenVMS. Everyone here at one point or another started using OpenVMS probably for one of these reasons: the reliability, security, or availability of OpenVMS. And we want to make sure that OpenVMS remains OpenVMS, particularly when it comes to these core strengths. And one of the things that we need to do to attain that is to at least reach the equivalence of functionality on Itanium on x86. Secondly, we need to adapt to a changed world, and a world that keeps on changing. The IT landscape has changed considerably over the last 20 years, and OpenVMS has hardly changed. And it means that we need to embrace modernization just to keep up with expectations. We need to recognize some of the challenges that are becoming visible on the horizon. To give you an example, the emergence of quantum computer technology threatens to take a lot of the security measures that we have and basically crush them. We need to be aware of that, and we need to start thinking about what we're going to do to counter that. We need to fit in with the rest of the IT landscape. We cannot afford OpenVMS to be an island by itself. And that means we have to be able to run in the same data center environment that customers run their other workloads in. And we need to make it easier to enable applications on OpenVMS to be integrated with other applications, because those applications are not the same as the ones they were 20 years ago. And if a company updates their financial systems and their, you name it, order picking system that runs on VMS cannot talk to the more modern financial system, in all likelihood, that company will rather decide to move from VMS rather than to pick a different financial system. As an example, to fit into modern infrastructure, I would like OpenVMS to become a full citizen on virtual machine hypervisors and in the cloud. Play by the same rules other operating systems play by, and make OpenVMS management in a virtual cloud environment no different from other systems management from the hypervisor point of view. Or better, yes. Then we need to enable application porting, whether it's existing applications on OpenVMS that need to move from Alpha or Integrity to x86, or even from VAX. Or if you're talking about applications that are new to VMS, bits of open source software that run on Linux now, that by porting them to OpenVMS enables applications on VMS to talk to the outside world using more modern methods. That means that our compilers and RTLs, and I'm looking at John in the back of the room now, it means our compilers and RTLs need to be jacks of all trades. They need to accommodate both old OpenVMS code and more modern code that comes from other platforms. And then I think we need to deliver improvements in a few other areas like performance, system management, and monitoring. We're a bit old-fashioned when it comes to those tools. Probably our documentation. Someone yesterday mentioned there is a Linux for VMS users guide. There should be a VMS for Linux users guide. And we need to do all this to improve the user experience on VMS. We don't want VMS to be the box that a newly hired systems manager looks at, sees the green prompt, and runs away from it. I'm not suggesting that we no longer have a green prompt, by the way. Don't misconstrue my words that way. So I want to give you a few practical examples of what I'm talking about in 4 different areas: software development, storage, networking, and the operating system itself. So talking about software development, in our Clang C and C++ compiler, we want to keep up with modern language standards. If you're taking some open source software now and it's written in C or C++, I mean, those are the predominant languages, you may find that our compiler throws up when you give it the code, because some of the features in those languages may come from C++. What's the latest one? 21?
Yeah.
Something like that. Right. So we need to keep up with that to enable application porting. Then we have several plans to improve the software development experience. For developers who are new to VMS and not as familiar with the platform, we provide tools like the VMS IDE, which is a plugin for Visual Studio Code. And that gives software developers who are unfamiliar with VMS a more familiar development environment. So basically, they don't have to learn EDT or LSE. And then our debugger on x86, we know that it's not up to what it should be right now. And we're working to give it the same functionality as our debugger on Alpha and or Itanium. And we're making progress there. Then some developer documentation needs to be written. We're getting a lot of questions now about porting privileged applications and porting drivers. There was a great session yesterday about porting drivers, and there's a white paper in the making, and eventually that will be turned into a porting guide for privileged applications. We may do something similar for porting Linux applications to VMS. And then compatibility. Supporting modern language standards isn't only a function of the compilers. Some functionality may need support in the runtime libraries, or even support in the operating system itself. For instance, our pthreads library lacks some of the latest pthreads functions. When it comes to storage, with the introduction of VMS version 9.2-3, which will be released in December, we're adding support for Fiber Channel on x86, which enables customers to use shared disks directly rather than over MSCP. In version 9.2.3, that support is limited to VMware using VM Direct Path IO. And because of the driver that we have for Fiber Channel cards, it's limited to HPE Gen 10 machines with an SN1100Q Fiber Channel card. We are going to add support for more modern controllers, 32 gigabit Fiber Channel cards that ship with HPE Gen 11 servers. And we're also going to extend support to KVM PCI pass-through so that you have a choice of using Fiber Channel with either VMware ESXi or with KVM. But looking further towards the future, I think that we need to get out of having to develop these drivers every time a new version of a platform comes out. So for storage, what we're going to do is we're going to develop an iSCSI driver for VMS. so that iSCSI is a fiber channel-like protocol that runs on top of TCP/IP, and it can be totally hardware agnostic. I wouldn't recommend running it over a 10 megabit Ethernet network. But if you've got a gigabit network or 10 gigabit network, this should be able to provide you with the same kind of performance that we currently get on VMS using fiber channel. And it gets us out of the you can only run on HPE hardware game. Plus, it would enable running full clusters in the cloud. And then finally, one of the things that we need to tackle is the ability to have a cluster common system disk on x86, just like we have it on Alpha and Itanium. And there are 3 different technical challenges that we need to overcome to make this possible. We need to teach our boot manager how to boot from fiber channel or from iSCSI. We need to make sure that our memory disk mechanism supports having multiple system roots. And then finally, we need to tackle the matter of the dump kernel, because our dump kernel is a full-fledged OpenVMS instance that is not cluster aware. And if you let that run from a system disk, which is shared in a cluster with other nodes, I see several people in the audience see the train wreck coming. So if you get the question, why don't we support cluster common system disks yet? This is the answer. It's more complicated, and it's an unforeseen consequence of how we decided to tackle the boot manager or the dump issue on x86. When it comes to networking, we have a pretty old TCP/IP stack on OpenVMS. And as some of you may know, our TCP/IP stack comes from BSD Unix by way of OSF1 digital Unix through 64. And like I said, it's pretty old. Most of the networking kernel code is probably about 20 years old by now. And we see that there's a demand for more modern secure protocols on OpenVMS. Customers are asking us for things like DNSSEC or NFS version 4. And what we find in a lot of cases is that the old TCP/IP kernel that we are running is hindering us, and in some cases us, from being able to implement these more modern protocols. So what we've decided to do, and this is a big project, what we've decided to do is to take a modern BSD operating system, to which FreeBSD, and take the kernel from a current FreeBSD and port that to x86. That means making it compile on OpenVMS, but it also means changing the cradle that the current TCP/IP stack sits in, and that provides a BSD environment. So we need to provide a more modern BSD-like environment for that ported TCP/IP kernel to sit in. So this is a fairly big project, but once we've done that, that is an enabler to providing more modern and more secure protocols on OpenVMS. And some of those protocols are things like iSCSI, which I talked about on the previous slide. It would enable the porting of NFS version 4. It could enable the porting of DNSSEC. OpenSSH, who runs OpenSSH today? How happy are you with it? Some people aren't. That's good to know. Well, we know that the OpenSSH solution that we have today, version 8.9, doesn't really tick all the boxes. And the main problem there, or the main cause of that, is that when we started the port of OpenSSH, we started with a wrong set of assumptions. We started with the idea that OpenSSH on VMS should be like OpenSSH on Linux, rather than be like the previously provided SSH solutions on VMS. And the OpenSSH port was done by people when they started who did not have a whole lot of experience with OpenVMS. And to be honest, we haven't given them the guidance that they needed. And that team has certainly grown over the years. And looking back at the code now, we have realized that it's probably not a good idea to try and fix what we currently have. So rather than doing that, we are going to sit down and come up with a decent set of requirements that satisfies everything that's currently wrong with OpenSSH on VMS and start the port from scratch based on those requirements. Another fairly large undertaking, but that way we start from the right set of assumptions and we start doing it the right way rather than have to fix everything later. Bob.
You know, one of the problems in the past with SSH and TCP stack in general has been that the security alarms on Cypher issues and the like come out at very great frequency, relatively speaking, and short fuses. What is needed, I understand the limitations of time, resources, and people, but Cypher changes as a separately upgradable fix without having to go massively around different products. As in a shareable image, they can slam in as an update, as a discrete update in all the boxes. It would be extraordinarily helpful.
Okay.
Because the compliance mandate comes down to update 447-2 is a vulnerability. 447-2 must be complied with within 72 hours. And when VSI is the long pole in that tent, it percolates right up the management chain as the
Okay. Noted.
detriment.
Thanks.
In many different dimensions.
Right. So we're going to report, and that will probably be version 9.9, which is like the latest. And then finally, with the new TCP/IP kernel, we can also start thinking about things like IPsec and WireGuard to encrypt any kind of network traffic. So we're examining whether we can use one of these to encrypt, for instance, cluster communications over IP. So this is not something that we've put a date on yet, but it's definitely on our internal roadmap without a date on it. So looking at the operating system, we need to do a lot of work on x86 when it comes to performance. And we've got some projects going on for that. We're working towards being able to fully build OpenVMS natively, using native compilers, using optimizations in those compilers. We want to reduce the use of memory probing. Memory probing is a mechanism to check whether a certain bit of memory can be accessed for read or write access from a given mode without actually performing a read or write. And on Alpha and Itanium and VAX, that was a cheap operation. It was cheap because the processor had an instruction that took care of all that. And because it was so cheap, people ended up doing it all the time. So you may have a function A that calls function B, and function A does some probing before calling function B, and then function B, whoever wrote it, said, well, I'm not sure if this has been probed yet or not, but since it's so cheap, I'll just do it anyway. So what you see is sometimes the same range of memory pages gets probed 3 times in a row. And that's fine when that's a cheap operation. On x86, however, to our dismay and amazement, there is no probe instruction in the architecture. So what we have to do to probe a memory address is manually walk the page tables from top to bottom to figure out, is this a page that exists? And if it exists, does it have the access privileges to allow this access? That is an expensive operation on x86. It may get a little bit better when we get to the optimizing compilers, but right now that takes on the order of about 2,000 instructions for a single probe. We want to go through some parts of the OS with a bit of a tooth comb to figure out where do we do redundant probing in an effort to eliminate that. And we're also looking at finding ways to do probes in a different way in a few different areas where it might actually be better just to take a page fault and handle that if something goes wrong rather than do the probing. But that requires a pretty tedious and conscientious engineering effort because you don't want to mess this up. And one of the problems is if you mess this up, it may not be readily apparent because it may be something that only shows up if a number of things go wrong at the same time. But once you hit that and you get this wrong, you may end up blowing the kernel out of the water and crashing the system, which we don't want. And then we're looking at a number of other improvements. Think about things like lock usage. There are other ways where we might be able to improve performance. So what we're doing now is we're running a lot of tests, and Claire is fortunately still with us, and he's running a lot of those tests for us, trying to identify parts of the OS where we can potentially make performance improvements. And what we then do is we try to evaluate what the potential performance gain would be and try to offset that against the engineering effort to come up with like the priorities of where are we going to spend our time first. We want to do some work in better coordination with hypervisors. When you're running a virtual machine in the data center or in the cloud, you have to play well and you have to be easy to manage. So right now we're working on some of the essentials, proper timekeeping on a virtual machine environment without having to use something like NTP to make that happen, which is a stopgap measure. Being able to gracefully shut down your VMS host from ESXi. We can do that on KVM because KVM uses an industry standard ACPI mechanism to accomplish a graceful shutdown. VMware ESXi, that requires the use of some part of VMware tools. So we're working on developing VMware tools and their equivalent on KVM. In the future, we may be able to support things like adding a gigabyte of memory to a running system in the cloud, or adding a few CPUs if I want to do end of month processing and take them away again when we're done. Right now, OpenVMS is not equipped to deal with dynamic changes like that. But there are some rudiments for that in the operating system because we had instant capacity at one point. So we might be able to leverage some of that, marry it with like the KVM or VMware tools and make these things possible. Not on the roadmap, but certainly things that we're thinking about. We want to modernize system management, and we've got some tools for that, like WebUI, which provides you with a graphical user interface that you can use if a user wants to have their password reset, or if you're out of quota, things like that. And for we have VMS SPI, which is like a tool for performance measurement and like monitoring of the system. And this is a modern tool that integrates with tools like Splunk that are used throughout the data center to aggregate that kind of data. So this all goes into playing nicely in a modern environment. And then in terms of security, we're adding features or thinking about adding features like stack smashing protection, where we can pretty quickly identify if something has corrupted the stack and end the process before more damage can be done. Or adding a better password hash to OpenVMS, because what we currently have is a little old. And if you manage to get access to the password database and copy it to a Linux machine, you can probably get all the VMS passwords in not enough time, or in too little time. Bob.
It's a very obvious comment to further, I'll just read this for the record. SHA-1, SHA-256 makes certification the higher security authorities a lot simpler.
Right, yes.
Statement of our hash function is a bad thing. Saying SHA-256 with appropriate salt, etc., is a much easier to justify thing.
I'll refer you to Doug Gordon for an answer to that.
No answer necessary, he's making a comment.
Okay. And then we're also working on code signing and secure boot. So we're signing execlets, making sure that we're working on that. It's not in 923. We just didn't make that, but we're working on signing execlets and verifying that what we load into memory as part of the executive is actually code that comes from us. We will extend that like further down into the boot path, and that will eventually culminate in supporting secure boot, where everything that gets loaded into memory as part of the operating system is ultimately rooted in a hardware root of trust. You had a question, sorry.
NST has recently released what finally they came to the right answers about password recommendations, length versus complexity and things like that. It would be really nice to see that kind of advice and practical information reflected in what Authorize actually does. The password length should be increased.
It is 64 and 9.x. However, not all access methods may accept 64 characters.
Sure.
But you can use this, 30 from 33 on to 64 in 9.
That's the maximum password length. What about updating the minimum to 12 or something like that?
Oh, that's completely in control of the system.
Well, what I'm saying is shipping it out of the box with 6 is
That's already up.
okay. All right.
Thank you.
There's
Feel free. I mean, find me.
yeah.
All right. So, sorry? Single sign-on.
We do that through external authentication.
Right. Yeah, we're working on external authentication. The Acme agent is part of 923 for x86, and we'll do some work in that area. One of the other things that I haven't mentioned here that we're looking at is doing multi-factor authentication, which is also like something that everyone wants you to do. So yeah, certainly thinking about that. Then I just want to show you some of our highlights for our roadmap, and these are some of the things that we can put some dates to. So December of this year, we're going to release version 9.2-3 of the OS, Gen 10 fiber channel support, HPE Gen 10, that 16 gigabit fiber channel, supported on ESXi. We have the guest console, which is a console interface that doesn't require an emulated serial port. So you can use that if you are running VMware ESXi with a license that doesn't allow you to create a virtual serial port. You can use that if you want to do something like vMotion, which is now possible with version 9.2.3 because of the guest console. And yeah, I mean, it's a limited functionality interface into the system. You can't scroll back, but for system management purposes, you shouldn't be spending most of your time behind the console anyway. Using the console, in my mind, is something you do when you're installing the OS, or if there's some emergency that prevents you from reaching the system using SSH. If you're using the console for your day-to-day systems management tasks, you're doing something wrong. June 2025, at the latest, we plan to release an update to version 9.2-3. Chances are that this will be the second update to it, but this is why we want to do an update around that time. We want to add support for HPE Gen 11 servers with 32 gigabit fiber channel cards. Just because that's what HP is currently selling. The 16 gigabit fiber channel card is not supported on the Gen 11 platform. And we know why, because it doesn't work. We've tried a lot of time trying to get it to work because someone at HPE had told us that, yes, it wasn't officially supported, but they had it working. That turned out to be a little bit misleading. So we wasted quite a bit of time on that, actually. So we have to update the driver to support the 32 gigabit fiber channel. We're pretty close to that. Usually when we update the fiber channel driver, it's simply a matter of recognizing the new PCI IDs and correctly resetting and responding to the speed. In this case, it's a little bit more evolved because QLogic, and this is something, it's actually pretty good that they're doing it, but it's causing us some problems. QLogic has moved to a secure firmware model. And part of what we do when we start the fiber channel driver is we have to read the firmware from the read-only memory on the fiber channel card and put it into the card's random access memory for execution. And the mechanism to do that is completely different between the older cards and this newer generation of cards. Once we've done this, the next step when we go to 64 gigabit fiber channel will probably be a breeze again, because we don't expect there to be any big changes there. But that's why this is taking us a little bit longer. And then, of course, we need to go through our internal qualification, run it with a clustered load, and really beat the heck out of it. We also plan to support fiber channel pass-through on KVM. That's also mostly a matter of qualification. And then around the same time, we hope to release OpenSSH version 9. We're planning a compiler update somewhere towards the end of next year, maybe early 26, where we will provide compilers that are built completely natively. Currently, we build most of our compilers natively with the exception of the LLVM backend, which is cross-built. And I think the C++ compiler is completely cross-built, or was it the C compiler? Right. So we want to get rid of all the cross-built stuff in our compilers. Then version 9.2-4. This is where I think a lot of good stuff is going to happen. We plan to go to field test towards the end of next year, and then go to production about half a year later. So we'll have a longer field test period than you're used to. We may have multiple updates of the kit during the field test to fix issues found in field test before the end of field test. And the reason for doing a longer field test is because this version will have the newer TCP IP kernel and iSCSI support. And we really want our customers to be able to use the field test period to test those features thoroughly and make sure that it works. And we understand that, especially moving from fiber channel storage to iSCSI storage, that will require some time just to get it set up before you can even start testing. So having like a 2 months field test period for that is just not long enough. We'll also put some things in that we've got that we pretty much have ready now, but didn't have the time to thoroughly test for version 9.2-3. Like, we have a driver for the VirtIO random number generator that would be able to feed our entropy pool in OpenVMS with like random numbers from the actual hardware on a KVM platform. And then past version 9.2-4 will of course have operating system updates, and there will be a new version of the operating system, but we're not planning that yet. What we are planning is some updates to TCP/IP version 7 and version 7.x, I've named them. And this is where we can start adding those more modern protocols that the new TCP/IP kernel enables. So this is where you might see things like NFS version 4 or WireGuard appear. And the reason why we're not putting any dates to that yet, or saying this will be part of version 7.1 or this will be in 7.2, is because we really want to get your input on what our priorities should be on. And Mike will have a session about networking. Is that today or tomorrow, Mike? Today. So Mike will have a session where he will go into some of the things that we might be able to do, and then ask your opinion on what is important and what isn't. So that's all I had. I have 4 minutes left for any last questions.
Yeah, on your newest SSH version.
Yeah.
Copy ID. So I can log in with a key instead of a password.
Okay. Does it? I'm not sure about the mechanics of that.
It's support OpenVMS or OpenSSH rather.
Okay.
Copy ID. Where you SSH in and you tell it copy ID instead of a straight SSH, and it sends your private key so you can log in the future securely without a password. Huh? SSH agent?
It uses SSH agent.
Okay.
Okay. Well, we've made a note of that.
Yeah.
Kim.
Apologies if this is already done, because I haven't checked the public roadmap for a while. Is this going to be added to the public roadmap, even with the TBD dates and stuff?
Let me see. So 923 is on the public roadmap. 924 is on the roadmap. TCP/IP 7 is on the roadmap. The compiler update is not on the roadmap yet, but like the current refresh is on the roadmap.
Yeah.
So once,
For me, even with the TBD would be fine.
right. Okay. Al.
Camiel, have you guys done any kind of analysis to find out, you mentioned at the beginning of your presentation that our VMS operating system is a little dated. Now you're coming in and bringing in devices that are going to exceed 10 gigabits significantly in the near future. Have you thought of what it's going to take to do to the kernel to be able to have our current I/O mechanisms, the operating system to be able to handle those kind of speeds? And the data repositories that have to back those buffers to be able to keep up?
Yes. Well, I mean, we've made some pretty improvements in our driver model, going to x86 using IOBDs instead of SWAPTs. So we're already doing some of the groundwork for that. And one of the things that we're looking at as part of like the TCP/IP kernel build is, or porting, is we can also take a look at like the path from the TCP/IP stack down to the network driver and see where we can make improvements there. Just specifically for network interfaces, and of course, if we're going to use the network interface for storage, this is very important.
So does that include the ARM support now to be able to leverage the onboard engines on the IP controllers? So you're now going into message passing mode as opposed to, as we do it today.
I don't know the specifics of that, and I'm not sure if all those mechanisms are available on virtual hardware.
They're available via the VM, but you have to have a driver that says, speak that way. I want to use onboard checksumming, onboard encryption, onboard this to reduce the VM's responsibility to have to constantly be.
Right. No, it's I mean, Mike is the one to answer in more details, I think, but we have that has come up in our meetings.
You mentioned before this roadmap the addition of VMware tools for things like resizing and other management that's not in here. So is that more of just a nice to have getting the actual VMware tools in place?
It's something that we haven't, like, it may well be that that's something that we can do for version 9.2-4 or maybe even for an update to 9.2.3. But because we haven't really sized that project yet, we're not committing to a date for that yet.
We know that things in the VMware tools, maybe not the whole package. There are things in there we absolutely have to have sometime, and that has been our thinking for a long time.
Yeah.
Can I tell you what they are? No.
Well, this is one of the, I mean, if you look at the roadmap like this, compared to what our roadmap looked like 8 years ago, this is a pretty light roadmap. And I'm doing that, basically, that's how I want to do it. I would much rather have a light roadmap and add things to it as we get there, but deliver 9.2-4 at the latest in June 26, rather than keep adding to the roadmap now and having to tell you it's going to be June 27. I don't want to fall into that trap again. So if you get questions about why is the roadmap light, this is why. Yeah.
Out of curiosity, like EIP 37, is that going to be?
Initially, it's going to be x86 only. Whether we will be able to do that on Alpha and Titanium, that it remains to be seen. We see several challenges there, and there are things that TCP/IP, that the new TCP/IP kernel enables that we will not be able to deliver on Alpha and Titanium because of compiler issues. We are over time. We have to go.